Okay, next problem. Again, we got some charts here. We're going to fill in. Let me get my calculator set up to do the filling in here. So if I plug in 100 into my function there, I'm going to get 1.9994. And if I plug in 1,000, I'm going to get 1.999994. And if I plug in 10,000, I'm going to get 1.999994. And if I have the number of nines a little bit off, that's okay. But we see that this is approaching 2. And so we're going to conclude that the limit as x approaches infinity of this guy is 2. And then if I do it again on the other chart, this time plugging in negative 100, I get the exact same values. Somewhat coincidence on this problem. I get the exact same values because the variables are squared. And so since the variables are squared, it doesn't necessarily matter. It doesn't matter at all if I put in a positive or negative value. So just a coincidence on this one that I get the exact same values back. But that is approaching 2. So we say the limit as x goes to negative infinity of f of x equals 2. And down below we see that graph. And notice on that graph, I'm going to draw a little line here. How about we do it in pink? I like pink. If I draw a horizontal line right at 2, we see on the right, over there, x approaches infinity, extreme right, graph approaches y equals 2. That my pink line there is y equals 2. And x approaches negative infinity, extreme left, graph approaches y equals 2. And again, negative infinity, extreme left, positive infinity, extreme right, and then your limit values your y-coordinate. Now notice it has absolutely no impact on the center of the graph. On the center of this graph, the guy's going down to 0. The center of this graph had an asymptote. And graphs like this one, a lot of times students will get it wrong, that they'll say x approaches infinity, so they'll look right here where the graph is going up. Well, right here where the graph is going up, those are y-coordinates, not x approaching infinity. This is y approaching infinity. And so when you're doing limits infinity, you are only looking at the extreme left and right. You're never looking at the center of the graph, assuming that center is defined by the origin. It's extreme left or right. Let's do it again. So this time we've got 3x squared over, or x squared over 3x. Let me get my calculator ready. So I've got x squared divided by 3x plus 9. And when I put in 100 here, I get 32.36. When I plug in 1,000, I get 332.336. And when I plug in 10,000, I get 3,000. This was supposed to be a 2 here, not that that's going to matter too much. 3,032 and 3,336. Okay, this is not approaching a fixed number. This just keeps getting bigger and bigger and bigger, so it's going off to infinity. And so we would say that the limit as x goes to infinity of this particular function is infinity. And doing the same thing over on the next one. Plugging in -100, we get -34.364. Plugging in 1,000, we get -334.336. And plugging in -10,000, we get -3,034.336. And again, we're not approaching a single fixed number, that we keep getting smaller and smaller and smaller without bound. And so we would conclude from this chart that the limit as x approaches -infinity of f of x equals -infinity. And then when I look at that chart, we see really the same things going on here. As x approaches infinity, so really I'm being really lazy with my graphs there and didn't put my arrows. As x approaches infinity, extreme right side of graph, the graph goes up forever. And so we're approaching infinity. Over here, the extreme left, as x approaches -infinity, extreme left side of the graph, graph goes down forever. Approaches -infinity. So again, the limits predict the graph can predict the limits. And again, notice it's only about the extreme left and the extreme right. It has nothing to do with the center. And again, when I give students graphs like this and I say as x approaches infinity, a lot of students will answer -1 here for me. Because at -1, we see the asymptote. The asymptote has nothing to do with this problem. When we're doing limits in infinity, x approaching infinity and -infinity, it's all about the extreme left and the extreme right, period, not the center. Okay, going on with that idea about the extreme left and the extreme right, limits infinity graphically. And we've really already said this. Graphically, the limit as x approaches infinity of f of x is asking what is the y-coordinate approaching on the extreme right side of the graph, and the limit as x goes to -infinity of f of x is asking what is the y-coordinate approaching on the extreme left side of the graph. So use the graphs to predict or to determine the limit as x goes to infinity of f of x and the limit as x goes to -infinity. So the limit as x goes to infinity of f of x. Extreme right. And let's do that in pink. I'm going to run out of room here, so I'm going to put up here extreme right. In pink. So let's draw a little pink line here. And it looks like to me And again, the graph's really small, so hopefully you're looking at your own copies of these things. That looks like that's about y equal 1.5. When I give you a graph, ballpark, I will allow decimals. Graphs are approximations, so decimals are fine. Limit as x goes to negative infinity, so that's going to be the extreme left. And we will do that in green. And so that looks like about there. That looks like y equals negative 1.5. And so we would say negative 1.5. Now there is no such thing as a two-sided limit when you're talking about infinity and negative infinity. That guy's done. So let's finish this last one up. Limit as x goes to infinity of f of x. Again, extreme right. Pink. So doing my best to draw a line there. And so, a little bit ballpark, if someone said it was bigger than 1, I wouldn't really care. Limits graphically are ballpark. 1 is close enough. I'd take anything in the vicinity of like 1.25 to 0.75. Limit as x goes to negative infinity of f of x. Extreme left in green. Well, extreme left is right there, going up forever. And so we would write infinity, that it's not approaching a fixed number, that the graph is going nearly straight up, so infinity. And that concludes this part of the lecture.